Okay, as we take a look at the area of regular polygons. So regular means, again, same angles and same side lengths. Polygons can be multiple shapes. So this time it looks like 1, 2, 3. We've got a pentagon. So notice what happens when we break apart our pentagon. We can break it into tiny little triangles, which when we line them all up like this, it kind of looks like a nice neat row. But in order to find the area of the polygons, what we have to do is we have to find the height of these triangles. So what is this? What is this? What is this? And so this area from the center of a polygon to its side is called an apothem. So we can see that right here. This is called an apothem. And it actually, again, when we break it up into triangles, turns into the height of our triangle. So if we think about this, to find the area of the polygon, I need to find the area of all of these triangles. So one way to do that is to think about, all right, the formula for a triangle is 1/2 base times height. Well, in this example right here, my base is S, my height is A, but then I also have 1, 2, 3, 4, 5, 6 triangles here. So if we think about it, this bottom part, the base of all our triangles, is kind of also like the perimeter. So I could take 1/2 my apothem times the perimeter. That would give me the area, 1/2 the apothem times the perimeter. Or instead of the perimeter, I can take my side length of S and then multiply it by n number of sides. So again, it's basically the same thing. It'd be like, all right, if this was 6 and I have 6 sides, I could do 6 times 6. Or again, add up the perimeter around the whole thing and it's going to be 36. So either way, I can still end up getting 1/2 the apothem times 36 or 1/2 the apothem times 6 times 6. Still going to be the same thing. Okay, so again, if I were to just kind of sketch this out, draw this out, I'm making a bunch of different triangles, something like this. So we have, again, how many sides? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. I have an apothem of 12, base of 10, and side lengths of 1/2 times the apothem times my base times the number of sides. 6 times 10 times 8. 480 inches squared. All right, this time we may have to use the Pythagorean theorem. A squared plus B squared equals C squared. Remember, C squared has to be the hypotenuse. So Mr. Larson likes leg squared plus leg squared equals hypotenuse squared. So again, if this part's 20, this part's 20, this part's 20, this is also going to be 20. But that's the whole thing from here to here. So I think, since I like using right triangles for my Pythagorean theorem, if I draw half of this triangle, I've got a side length of 26. Half of 20 is 10, and this is my goal to find this. So I'm going to say 10 squared plus x squared equals 26 squared. Again, leg squared plus leg squared. The height is one of my legs. 100 plus x squared equals 676. Subtract 100, x equals 576. And the square root of that is 24. So the height is 24. But that's not the answer, because now we have enough to use our area formula. So area equals 1/2 times 24 times, This time I have a base of 20, and the number of sides, let's see here, 1, 2, 3, 4, 5, 6, 7. This is 7 sides. Yep. 7 triangles. And then times 26. So it's going to be, basically I'm using this formula right here. 1/2 times A, excuse me. I think I've got an extra piece of information in here. 1/2 times A times N times S. One half times A times N, which is 7, times S, which is 20. So I don't need the 26. So that's my fault. That's where I goofed up. Now we can do 1/2 times 24 is 12. 12 times 20 times 7 gives me 1,680 centimeters squared. Use special right triangles to find the apothem and side length of this regular hexagon. So let's think about that. All right. Normal shape has 360 interior degrees, and regular means they're all the same. So all of these angles are going to be the same. So if I divide by 6, 360 divided by 6 gives me 60. So I know that each of these angles right here is going to equal 60 degrees. So I'm going to pull out this triangle right here. I'm going to pull it out. I'm going to say this right here is a right triangle. This 60 is not the entire thing, okay? It's going to be cut in half, which means this angle on the right side here, because it's cut in half, is going to be my 30. And then if I have a 60 or a 90 and a 30, that means the only other option is to have 60. So again, our base for a 30, 60, 90 is across from my 30 is X, across from my hypotenuse is 2X, and across from 60 is X square root 3. So if my hypotenuse is 20, then that means the height is going to be 10, and then the leg is going to be 10 square root 3. So we now have enough information. Again, area equals 1/2. My A, my apothem, is the height. And then my base is 10 square root 3 plus 10 square root 3, which is going to give me 20 square root 3. And then this is going to be multiplied by 1, 2, 3, 4, 5, 6. So 0.5 times 10 times 6 times 20. It's going to give me 24,600 square root 3. And again, you could multiply that out times the square root of 3. You get about, it's approximately 42,608.45. So again, if your answer was just in square roots, it would be 24,600 square root 3. If you wanted to get a total number, you could do it like that.